Hey everyone, welcome back to my channel. Today we are diving into Amazon Rekognition, a powerful cloud-based tool that lets you detect faces, celebrities, inappropriate content, and even extract text from images and videos. In this hand-on tutorial, I will show you how to connect to Rekognition using Python, analyze media files stored in Amazon S3 service, and bring real-world AI use cases live, like user verification, video moderation, and more. So let's jump in. But before we dive into the code, let me introduce you to Amazon Rekognition. It is a powerful cloud-based computer vision service from AWS. Rekognition lets you analyze images and videos using deep learning models without needing any machine learning expertise. You can use it to detect faces, recognize celebrities, extract text, identify unsafe content, and even moderate user-generated media. It is built on the same technology that Amazon uses to analyze billions of images and videos on a daily basis. And it keeps learning and improving over time. So this is really a powerful advantage. So whether you are building a smart media platform, a safety compliance tool, or just exploring AI, Rekognition makes advanced computer vision accessible through simple APIs. If you go to Amazon Rekognition website, you can find the benefits of this service, and you will find more videos on the features that they have, like face liveness, face detection, and analysis. You will find custom labels, text detection, and more features like label celebrities recognition, and even video segment detections, along with use cases and what their customers experience. In Amazon Rekognition developer guide, you will find all what you need for the key capabilities like image analysis for object, scene, and concept detection, text detection, unsafe content, celebrity recognition, facial analysis, custom labels and image properties, and key capabilities for video analysis like object, scene, and concept detection, text detection, people pathing, facial analysis, celebrity recognition, unsafe content detection, video segmentation, and facial liveness, along with use cases. In the first part of our Amazon Rekognition tutorial series, we are diving into how to detect faces and celebrities in both images and videos using Amazon's powerful deep learning-based recognition service. And whether you are working on media apps, surveillance systems, or smart galleries, this technology can power real-time scalable facial recognition. So let's get started. Okay, so I'm using today AWS SageMaker Studio, and I have a studio, so I'm going to open the studio. So once I click Open Studio, it will take me directly to my SageMaker Studio, and I have Jupyter Lab. Once I click Jupyter Lab, it will show me all the Jupyter Labs that I have. I have a small instance for this experiment because I don't need much more power because I'm not computing or training any models or even inferencing. Okay, so I'm using MLT3 medium, and you will find more about the cost on Amazon cost. That's why at the end of this session, please don't forget to release your resources. So I'm running the space. As you can see, it's starting now. I can also run it from here. So I'm waiting for it to start. As you can see now, my lab is running. So I'm opening my lab. Okay, this is our Jupyter Lab environment on AWS SageMaker, and I'm opening our lab for today. Okay, let's now start our lab and our practice. So we're going to use technologies like Amazon Rekognition, Boto3, which is AWS SDK for Python, Jupyter Notebook, and AWS 3 for storing images and videos that I'm going to use in this lab. So let's start by environment setup and initialization. In this section, we are going to import Boto3 SageMaker, HTML display, and images image from IPython.display. From below, I also imported image draw, and image font. We imported the time and OS. First, I'm initializing our Rekognition client and S3 client. And S3 is an Amazon storage service where I can upload and download all my files into buckets. Okay, and this is the media file that I'm using on my bucket. And if I click it, I will find all the files and videos that I'm using. You can easily click any file and download it. Okay, or you can upload more files to your bucket. So let's go back. So first of all, I'm defining the session for SageMaker. Then I will get the execution role. I'm getting the default bucket and the region name. And make sure that you choose a region that provides the service that you need to use in your experience. So I'm defining now a client from Boto3 for recognition service, and I give it the name Rekognition, and another client S3 for S3 clients. Okay, so let's run this cell and then run this one as well. Now I'm creating a temporary folder, and I give it, and I'm storing its name in a temp folder variable. Okay, and now we are building a useful help function that's called draw bounding box. The objectives of this function is, once I send it an image along with bounding boxes, so these are the boxes with colors that you see on faces or on objects in any image or video, I want this function to draw all the boxes on the image that I sent. I'm defining my color palette that have all my colors that I have. Then I'm defining the image directory, which is the temporary folder that I have here from my image. And now we can download a file. So I'm downloading the image frame from my bucket into my image directory, okay, using S3 to download file. Then I'm opening the image directory and get the bounded image. Then I'm drawing the image. I'm getting its size, width, and height. I'm defining the first color and the maximum colors that I have in my palette. And I'm defining the box lines. So I have the 4 lines. And for each box, I will have X1 and Y1, X2 and Y2. So these are the coordinates for the box that I want to draw. Then I'm calling the draw rectangle. I'm defining all the lines for this rectangle and even the color, and saving this image and display it at the end. Okay, so I'm running this help function. Now let's start our face recognition. The first image that we have, I have an image shot from the movie MI6, and I'm a big fan for Tom Cruise in this movies. So I'm defining the file name, and I know that it is inside a folder called media, mi6.png, and then I'm generating a pre-signed URL. I'm getting the object from my bucket, and these are the arguments and the parameters that I'm sending to the S3 generate pre-signed URL, and the image file name. I'm defining the width and height, and displaying the image. And we can see Tom Cruise and Rebecca standing behind him in one shot of this movie. Now we call Recognize Celebrities API from Amazon Rekognition. This function or this API will define many information for us for this in this image, including the name. It will give us ID, URLs if you want to know more about these celebrities, and facial attributes. Now I'm calling the Recognize Celebrities API from Rekognition client, but sending all the arguments it needs, the bucket name and the image file name that it's going to use. Then I will receive the JSON response inside a Recognize Celebrities response. If I display the contents of this JSON object, it starts by celebrities list, including a list of all the celebrities that it detected. And for each celebrity, you can find links for Wikidata and IMDb links for this celebrity, along with its name, gives an ID. And then the bounding box for this face with width, height, left, and top. And this is this is the information that we send to our helper function, along with the confidence, how confident the model is, and landmarks for the face features, like the mouth left, mouth right, nose, eyes left, and eyes right. In addition to the bold and pitch, along with more emotions information, like if he is calm, confused, sad, disgusted, and so on, with their confidence. Okay, and the smile, along with the gender information and confidence. Followed by that, it's the second celebrity it detected in this image, which is Rebecca Ferguson, and the same information, the bounding box for the same, the landmarks for her face, and emotions that it has in the picture, and the gender. There is also another list which is unrecognized faces. So these are the faces that it did not recognize as celebrities, and the result of this request, which is 200, which means it's a successful call. Okay. Now I need to parse and visualize the recognized celebrities. So I defined an empty list called bounding boxes that will call the list for all the celebrity faces from the JSON response that we received, and I will store it in all celebrities object, and I will loop through it, and for each bounding box that we have, I will append it to my empty list, and I will send this image along with this bounding box to our magical helper function and print the number of celebrities found. So let's run it. As you can see now, we will find a bounding box for Tom Cruise and bounding box for Rebecca Ferguson. Okay. Now let's try Amazon Rekognition Celebrity Services for a video. Again, I stored this video on my S3 bucket under the folder Media with the name MI6 trailer. So this video is approximately 33 seconds from the MI6 trailer. So I trimmed part of it as part for this lab. I'm going to get the pre-signed URL from S3. So I'm defining the bucket and the key, which is the video file name, the video S3 URL. I'm using a URL inside my HTML tag, and I'm displaying the video for you. So now let's show you part of this trimmed trailer that we have. Okay, now I want Amazon Rekognition to recognize all the celebrities and persons in this video. I will call Start Celebrity Recognition API from the Rekognition client, and I will define this job as Rekognition Video Celebrity Job. I will pass arguments that shows the bucket and the video file name for this task, and this task is asynchronous, which means it will take time to run. So I need to get its job ID. So Amazon stores a job ID for each job they run, and I will store it inside Rekognition Video Celebrity job ID variable, and I will print it. So you will find AWS job ID is, and you will find like a long unique ID. So I will run it. It will show another job ID. Now I'm pulling the Rekognition job status. For the job ID, I can get the celebrity recognition with this job ID sorted by timestamp, and as I will get the job status feature for this job, and as long as it is in progress, just wait 5 seconds, print me a star. So this is like a progress bar that we see, okay? And then continue this loop. At the end, when you are done, just print me what is the job status, if it's successful or not. As you can see, it took some time here. At the end, it tells me detecting celebrities in video job has finished successfully. So the job status is succeeded, okay? And it gives me how long time did it take. Of course, this time will depend on your video length and quality as well for your. So let's examine what is inside this JSON object, okay? So if I run the cell, it will be like a long, really list of all the celebrities, because this is like almost 33 seconds. So you will get a long list for it. So first thing you will see is job status succeeded, and then some video metadata like the length and frame height and width and the color information. And then we will have a list of celebrities. For each celebrity, we will find the timestamp for the occurrence of this celebrity or the detection it found in video, URL for more information, the name of the celebrity, it will give him an ID, the confidence, and the face bounding boxes, marks, and more other information, including the gender. Then another timestamp, the celebrity, also Rebecca, and so on. So because Rebecca occurred in more than one frame, it's normal that it will detect it in different frames. Okay, as we saw, we have a long list of information inside the JSON object that we received. So let's extract and summarize all the celebrities' appearances. So in this cell, I have an empty dictionary celebrities and a title string, and along with two empty strings that we will use to generate the extraction or the summarization for this video. So for each celebrity I found in my celebrities list, if this is a celebrity, then give me its confidence, okay? And if this confidence is above a certain threshold that I can define just to focus on some celebrities, or just to make sure that recognition service is really confident of this image or this face that it detects, get me the timestamp for this celebrity object, and then give me the name of the celebrity that is detected, and then I will empty string called video details that there is a celebrity found at this timestamp and with this confident, and I will write the confident. If it's not already in my empty dictionary, just add the celebrity name to print it later. After this loop, I will go through this dictionary and I will print all the names and the list of all the celebrities that it found, including Tom Cruise, and by the order of their occurrence and detection in the videos. Then more details for each celebrity found. Now let's try Amazon Rekognition with a picture of mine. So I stored one of my pictures on my bucket inside the same folder, and I stored the path inside my celebrity picture variable, and I passed this as my key along with the bucket name to the get object to generate a pre-signed URL from S3, and I'm displaying my image. Now I will pass my image along with the bucket name to Rekognition client and storing the recognized celebrities response inside the JSON object, and let's print it. It defines me as Abdullah bin Nasser bin Khalifa Al Thani. And it gives me an information, and this is what I was really interested in, which is the unrecognized faces. So I'm celebrity, but it's not under my name. So this should be the list where Amazon Rekognition will store all the unrecognized faces. So there are bounding boxes on these unrecognized faces, but as long as I show you in this object response that unrecognized faces is an empty, so I'm showing the image and I'm defining an empty list for the faces bounding boxes inside this list, which is empty. So it didn't define me as unrecognized, it defined me as a celebrity. That's why this list is empty. So I get the faces list from this list, which is empty. So if there is something there, I will loop in it, I will get their bounding boxes, and I will send it to my magical bounding boxes. It shows the image with no bounding boxes. And this is the end of our part 1. That wraps up part 1, where we explored face and celebrity detection using Amazon Rekognition. We saw how easily it can identify facial attributes and famous people in visual content. I know we saw that Rekognition has detected me as a celebrity. Maybe we need to tune some parameters in this. Don't forget to release resources and shut down any instances on AWS that is running. I'm showing you now when I was building up this notebook, it cost me like 0.19 cents US dollars. In the image processing for 22 images and trials I have done, it cost me less, almost 2 cents, but for the video it cost me like 17 cents for that, so a total of 19 cents. Okay, so don't forget to release resources and shut down any instances on your AWS. Share, like, and subscribe if you learned something. You will find the link for this notebook in the description below. Coming up next, content moderation. Stay tuned. Like the video if you learned something, and don't forget to subscribe to catch up part 2. Thank you.